All right, we're back. So, we've been working on this sketch API package in Elm to let us make nice little generative art sketches. So the problem that we were just talking about before the break was how do we give ourselves the ability to define essentially variables or constraints in our sketches. So what we're working towards is having the angle of these lines depend on their position. But before we get to that, we want to be able to define a random value and use the same value in multiple places. So I was thinking a bit about that on the break. And here's what I came up with. If we add a way for these values to have IDs, then we can have some kind of context as we're rendering, which records the values, or caches the values, I guess, for each frame. So let's see if we can do that and see if I think it'll work, but it may be kind of ugly. Like, we're making this nice little API a fair bit more complicated, which maybe there's not really a good way around it. So let's try something like this. We're going to add this new thing called named, and we'll attach a tag to it, and then we'll be able to use that in a cache lookup and only generate a value for a particular name once in each sketch, or each time the sketch is rendered. So we want that down here, named, and that'll go with the values. So I guess that can go here. And this will it'll take a sketch number and give back a new sketch number. And I guess we'll just give this a name and create the new case for it. So then our toFloat. Okay. So then we're going to have our named number with the name and the child generator. So we're also going to need some kind of context to store this in. So I think we're going to do that here. So we'll change this seed to take a context. And that will have a seed in it. And it's also going to have a cache. And that'll be a dictionary from names to floats. So this will be the float cache. Then here, we're going to use context. And these need to be colons. Okay. So if we get one of these, we want to we want to try to get out of the dictionary the name from the context.float cache. And if we get nothing, then we're going to get the new value. And we will do that by using toFloat of the child and give it the context. And we'll get back the new context. And let's see, then we want to take the new value and store it in the dictionary. So the tuple we're returning is the value, and then also the context the new context. But we're going to change the float cache to insert the value into it. And if we do get a value out of the cache, then great. We're just going to return the value and the context. Okay, so we have an error somewhere. Oh, we haven't imported dict. Okay, and then we changed this from being a seed to being a context. And then I guess we have to restructure this also. This is going to be value comma new seed equals this in. Then we will return the value and the context, but with the seed equal to new seed. Okay, cool. And then toColor also needs to change to take a context. And the initial seed is going to be context.seed. And then at the end, we're going to return the context with the new seed. Then here, we're going to have the same thing. When we render the shape, we want to take a context instead. So that means here, context. Oh, and actually all these seeds are just contexts now. And the same thing here. All these seeds are now contexts. Alright, so what else do we need to fix? In our update function, okay. So then our list of seeds, if we're rendering a shape, I think we don't need to keep the context around. The context is only going to be used for rendering a particular shape or a particular scene. So we'll just pass the seed, and the float cache is an empty dict. And then the new seed, this is the new context, and the new seed is the new context.seed. Oh. Context.seed, cool. I spelled new wrong. Okay. So render seed. Yep, and then we need to make that same change down there. Whenever we render the shape, we're going to give it a context instead of just a seed. Then what else? On line 260, the color, oh, okay, and these are all contexts in here. Okay. So that was kind of a big refactoring. Sorry I wasn't able to talk through a lot of that. But it looks like this actually worked. So we've basically created this context object where every time we render the scene, we make a new context with an empty cache. And then that cache keeps track of named values. So if we refer to the same named value multiple times, we'll get the same value during every rendering. So that looks pretty good. Let's see. So now let's see if we can actually do what we originally intended. So I'm going to put the Y position back. And now what we want to do is create this base angle, which is calculated off of using this other stored random value. So why don't we commit this first? And we basically added the named. That was kind of like a complicated thing to add. Implement sketch.named. And let me push that up. So now let's see if we can calculate this base angle. And then rather than rotate, we're going to use base angle. So my thought here was that we would calculate based on another sketch number, and then we would just give it a function. Let's see, are my parentheses right? There we go. And can we even get rid of the parens around the lambda? No. Okay. So we'll give it a sketch number and a function, which will produce a new value. So let's write this function. So we have named, move, random, always. Okay, let's stick it down here, and the colors can go at the bottom. Okay, so we have named. Now we're going to have calculate, which is going to take a sketch number and a function which takes a float and gives a new float, and it'll give us back a new sketch number. So this is maybe not the best thing, because we're going to end up putting a function now into our data structure, which is going to be stored in our model essentially. Although I guess we're not actually storing the sketch shapes in our model at all, so maybe that's not a problem. That's interesting to think about. I guess we're never storing the sketch stuff in the model, so maybe it's fine that it has functions in it. So I'm going to call this base and fn for our function. So this will be a calculated number with a base and a function. So let's add that to our data type. This takes a sketch number and a function from float to float. Okay, so now what errors do we have? Great, we have not handled this on line 249. So let's handle this. Calculated number, base, and function. So we're just going to take the toFloat. So we're going to do this to start with. We're going to toFloat the base. We'll get a new context out, and then we're just going to return a value produced by calling the function with that value and give back the new context. Got it. Okay. So did that work? So the way this worked in my processing sketch was that you could kind of see these waves appear over time due to the constraints of the angle being put on with the X position. So we'll kind of have to wait for this to run to see what it develops into, but it looks good actually. So all the lines here in the center all look horizontal, and then they kind of dip to the right and dip to the left. So cool. That actually looks pretty good. Unfortunately though, it also seems to be running really slow. So that's not ideal. But the API does seem to be working, so that's good. Let's try doing one more thing, and I'll let this run. Hopefully it doesn't crash the browser. What we want to do is add an additional random value to this base angle. So I think we just want a way to combine two sketch numbers. Let's try this. So we might have something like sketch dot combine base angle, or I guess we can do like a plus base angle with this random number. And let's see, did I mess up my white space? Yes. Okay. So then let's add our combine function. We'll put that after calculate. Oops, where is that? Here we go. Combine. This is going to take a function that takes two floats and gives back a float, and it takes two sketch numbers, and it'll give us back a new sketch number. And yeah, if you look at this, this is actually kind of interesting. It basically is taking a function that takes two floats and gives a float, and it's giving back a function that takes two sketch numbers and returns a sketch number. Okay, so here's our function, and let's just call these A and B. Combined number, and we'll just store that. Then let's add it as to a type. And we'll have our float, 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 and sketch number and sketch number. And then we just need to implement this. All right, so here's our switch. So we have our function and A and B. And now we're going to do something similar to this. But we need to destructure both of these. So this is A value and B value. Context 2 equals toFloat of B with context 1. Then we're going to end up with A value, B value, and our context 2. Yeah, and as Tenepi is mentioning in the chat, calculated number and combined number are basically like our map 1 and map 2 functions for this. Cool. So it looks like it might be working, but it's kind of hard to tell until it generates a bunch of stuff like this. And also my CPU is pretty high. I'm going to bring up the task manager and just double check that it is in fact this Elm app that's slow. Yeah, so that's using half my CPU. So this is super slow. Probably partly because we're manipulating a bunch of objects to do these math calculations, but also probably because at the moment we're just storing the seeds and recalculating every frame, including regenerating all the random numbers every time. So actually, why don't I commit this and then see if we can add an html.lazy in here somewhere to speed this up. And then we'll probably wrap up for today after that. Okay, so we implemented sketch.calculate and sketch.combine. Okay. So we can use html.lazy to operate on HTML nodes and basically cache them for a given input. That may or may not be a good thing for this particular program because we're going to end up caching a lot of stuff. So we might have a problem with memory, whereas now we have a problem with CPU usage. But let's give it a try and see what happens. So this render scene is what produces the HTML message, and the inputs to this are the size, a color, a shape, and the list of random seeds. Okay, so we can't put lazy directly around this because the list of random seeds is changing every frame. So what we would like to do is cache this part, what turns a seed and a shape into, what is this, a render.form. So let's see. So there's no lazy in core. Let's go to the HTML package and look in here. So this delays the building of virtual DOM nodes. When diffing old and new virtual DOMs, it just checks if the data is equal. Interesting. So the problem is we're using this graphics library to produce these forms, and these forms are not virtual DOM nodes. And there's no lazy even in here. So that's unfortunate. Hey Proton, welcome back. I didn't see when you cut off, so I'm not sure how much you missed. But we basically have our sketch working, and we've defined, we can define reusable values and define calculations based on other saved values. And it uses a ton of CPU. So let's see. I know there's another package for laziness. ElmLangLazy. Okay. And this is in the ElmLang thing. So this is, I guess, a whitelisted package that uses native code. Let's take a look in here. Source. Yeah, there's native code in here. And it does the memoizing in JavaScript, which makes sense because you can't, like, memoization is not a pure function, so there wouldn't be a way to implement that in pure Elm. Yeah, I guess a few people have been having trouble with the stream freezing up today. I can't tell anything wrong on this end. It's been uploading consistently, as far as I can tell. So it seems like maybe there's some trouble on the Twitch side today. Cool, glad it's working now again. Okay, so let's use ElmLangLazy and see if we can make this a little faster, more performant. So let's do Elm package install. And we're basically going to use this function to create a lazy, and then we're going to force it later. So does this actually cache, I'm wondering, now that I'm reading this. Compute everything up front, compute it when you need it, compute each graph, and save the results. Okay, so this presumably is doing the caching. Applies lazy. Okay, cool. Well, let's try this out. So what we want to do is change this part that takes a seed and a shape and turns it into a resulting excuse me, a resulting graphics form. And I guess we need to keep the lazy instance around. Let's see, this might actually be hard to do. So let's look in the native code in here. Is forced false. So this has a value. And returns the value if it doesn't exist yet. So memoize is used as a function in here. And it memoizes each time you call lazy. So what we need is, well, we can't keep creating these lazies. We need to create one for each seed, essentially. Yeah, so this gets kind of complicated, because we'll have to save these lazied values. So we have a map. Lazy produces, takes a unit, and gives an A back. So we would really have to keep all this in a dictionary. Okay, and we have to calculate this up front. Like, the first time we render it, we have to calculate it anyway. So I'm realizing lazy is maybe not a good match for this. What we really want to do is store the current seed, and then for all the previous frames, we just want to store the resulting shape that we get back. So let's try doing that. So we're going to have our current seed, and then we're going to have our past shapes, which is going to be a list of render.form of message. I guess it can be a never, because I don't want to add a type variable to this state. Okay, so then the seed, the initial seed is going to be random.initialSeed0, and the past shapes is going to be an empty list. Then current seed, we can basically put this back to what we were doing before. This is model.seed. And then this is the new context.seed is that. Okay, cool. And then what we'll want to do here also is add to the past shapes. So we'll actually get the shape here, right? New shape. So we'll have the past shapes is also going to equal the new shape tacked onto the old past shapes. And then what's going on down here? Our init doesn't match. No, the view doesn't match. Ah, okay. The view doesn't match. So here, our view, where's the view? Here it is, calls render scene. So actually we just want to pass the model.seed and then the model.past shapes. That means render scene needs to change. So it takes one random seed now, and then the list of render.form nevers. Okay, so first we want to render the current shape. Then we want to take the past shapes and stick them in a group. And actually that should be all. Okay, actually this will give us an HTML never. Which is going to complain doesn't match. Okay. So let's see, what's the quick way? We basically want to map this html.map, and if we get a never value, which we won't, debug.crash. And HTML, that's in app.map. There we go. Okay. So that was just kind of some trickery, I guess. We have this, whoops, where it is, this scene state. We have render forms that we don't know what kind of message they produce. We could have put a message variable here, but then because this is in a type alias, we'd have to add it here and then have this variable everywhere a scene state is used. So instead I decided to just make this say that these forms can never produce messages, which is actually correct. But then because we've specified a concrete type here instead of a variable, now when we create this thing, we get HTML that produces never, but we want this to just be a message again. So we use this function to convert the never into just any unknown type, which we can do because we know that never will never actually give a value out, so this function will never actually get called. So I don't know if that trick here was worth it to keep that type variable out of the scene state definition, but that's what that all was about in any case. Okay. So we're seeing it work. And actually the CPU usage does seem a little lower, but I'm not sure we can really verify that particularly easily. Oh, okay, so it's at like 30%. Let's stash my changes. And see what happens here. So this is the old version, and interesting. In this case, the CPU is like steadily climbing. So now it's at 22, 24%, 26. Yeah, that's interesting. And it kind of makes sense because every frame, it now has to recalculate each frame every new time. Yeah, and the CPU usage keeps climbing. Okay. So now, let's unstash this again and see how this goes. Alright, so there the CPU's at 11%, 12, yeah, so it looks like it's still climbing again. Although it does seem like it's climbing slower. Maybe that's just my imagination. Yeah, so ultimately the fix here would be to use the HTML canvas somehow. There's not really a good Elm package at the moment that can do that, but there is a plan for it in the future. I don't know if anyone is working on it right now at the moment. So ideally, we wouldn't want to keep the entire snapshot of all the past frames. Like, that's a huge performance problem. But in any case, I'm oh, whoops. I just killed the tab myself. I'm relatively happy with this. We do have this one weird thing where if you want to refer to a variable that you're using elsewhere, you have to use this named thing to define like a named variable. And then also these calculate functions in combine are a bit kind of ugly to write. So those two things aren't ideal. But a lot of this stuff was pretty nice for just being able to define random values. So yeah, I'm not entirely sure how I feel about this overall, but it was definitely an interesting exploration. So I'd love to hear people's thoughts about this in general, or if you know a nicer way to design an API that would let us do some of this stuff, especially more of the like programming related stuff. That would be interesting to hear. And yeah, I think that's it for today. I am gonna probably try doing some little Elm apps throughout November. I don't know if I'll get to one every day like I was mentioning before. Let's see if I can find this Twitter account. Codevember, yeah, here they are. So if you follow this Twitter account or look for this hashtag, there's going to be a bunch of people participating in this and doing little code sketches. I don't know if anyone else is planning to try to use Elm for this, but I am going to try to do at least a few in the month. Maybe I can get to one every day. We'll see. But yeah, thanks for tuning in today and following along on trying this experiment of making a graphics API. And I will see you. Well, I'll probably be streaming before next week if I'm doing some of these code experiments. So I will see you next time you tune in, or next time you watch on YouTube. So thanks. Have a great Halloween for those of you celebrating that. And remember to research your voting choices for your local election. All right. See you next time.